Time for another draftphysics.com, debatephysics.com also, but nobody reasonable to debate with. So I just made this video, and of course the old silly technical problem showed up, and so, fuck, yeah, that's all you can say. Damn it. And so I have to do it again. Let's see, what is page one? Jeez. Yeah, I can't tell, but anyway. All right, so Dispar Lab and Gosling are both contriving experiments to get away from this experiment. You know, where you put a one mass four distances and a four mass one distance, and it oscillates perfectly, and it proves the two things are the same amount of energy, the same amount of force, blah, 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 blah. So they're trying to find some way out of this by contriving all kinds of perverse ways of doing the experiment. All right, so the Dispar Lab one is the important, stupid fun motherfucker this guy is. All right, now that should be better drawn over here. Yeah, here. So he takes, he's hitting, he's going to do the off the surface cliff experiment. So you're just going to hit something with twice the, now he has timing gates, so he could just measure velocities. But anyway, he's going to shoot them off the cliff, see how far they go, and obviously twice the velocity, twice the distance. Should be the outcome. And so, but what is he doing? He's pushing a square nut. So I guess I should put a circle in here so you know. So I understand it has this, whatever, 6 sides thing. 1, 2, 3, 4, 5, 6, 7, 8, 8-sided. All right, and and he's using a round stick. Okay, so he's pushing a round stick against a frickin' 45-degree angle piece of metal, and his expectation is the energy is going this way. When clearly, like even a 5th grader could pass this test. The 5th grader could say, ooh, well, this will lift up and then this stick will go right underneath it. So you'll only get a tiny amount of energy in because you're going to be pushing it upwards. As it goes up, it's finally going to leave, and the stick's just going to go right through without pushing the rest of the energy in. And even if you got all the energy in, you got it in the wrong direction. So it's not going to do you any good because it's going in the wrong direction. So even, a 5th grader could figure out force in this way, round object against sloped surface. Yes, your energy is not going this way, okay? It's not going to happen. So that one is so damn stupid, and you're just saying a 5th grader could figure out how that's not going to work. But Dispar couldn't figure it out. All right, too big an idiot. Too big a cheater, frankly. That's all he's about is the cheat. How can I cheat the truth? How can I evade the real subject, which is you don't really believe it takes 25 times the energy to spin a wheel 5 times as fast. You know it's not true. And you're just playing a game here. You're just here because you think you can gain some points because actual physics hasn't done any of these experiments, and we don't have any high-speed camera, and we don't have any of this, the real quality stuff. And so you think, like Lady Chartelet, you can fool people by doing a little show experiment, denting clay with round things, or pushing, angular nuts with round sticks. You cheater, you pathetic cheater. His other experiment was so bad too. So, he's going to put the weights on the other side. One's a 2 mass, and so the 1 mass he puts, through the mass. And the 2 mass, it's only through half of one of the masses and the other one's dangling below. So they're obviously not centered. Now on a wheel that if you were to take a 1 mass and balance a 2 mass on a wheel, they would have to be across from each other. They can't be at some angle. If you put the 2 mass down here, it's not going to work because now there's more weight on one side of the wheel than the other side of the wheel. You've lopsided the wheel. So obviously when you're rotating things, you do have to consider that you can't do it this way because it changes through the rotation and the mass on one side of the wheel versus the other. You have actually more mass on this side of the wheel than you have on this side. Obviously, it's not a balanced wheel. So failure again. And and then his other experiment, he has some kind of dopey fulcrum that is so bad, that he gets maybe 5 oscillations. Now when I did Where's the experiment? Well, this was the experiment here. Okay, you know, the one one mass out here, the 4 mass here. Okay, they say that's 4 times the energy out there. When I did it, it oscillated for over 5 minutes. Maybe 10. I mean, it was a very long time. Not 5 oscillations. No, it oscillated. It just kept going and going and going. No friction. So obviously he has a terrible fulcrum. And that's why he can make the things oscillate at different rates, is because they have different friction. Obviously, when you put two masses on, the whole lever weighs more than when there's 2 1 masses at the other ends. Obviously, the whole lever weighs more, so you know there's more friction. So you have to have a very frictionless pivot, or that's going to show up in your results. Now, if you have a really good pivot, it doesn't bother anything, but that's not what he had. All right, and then Ian Gosling. Okay, so again, just this is what, again, like I said, if I put this on a test and gave it to 5th graders, I'm putting force in, round stick hit slope surface. You think the 5th graders could figure out that the energy's not going this way? I think they could. All right, so that's just my lever experiment, balance. And so Ian Gosling is playing a game. He's putting, instead of just doing the simple experiment, he's trying to contrive some way he can put masses on the other side. Okay, so there's a fulcrum here, and he's got a little launcher here for a ball. All right, so he's playing games, trying to put more weights over on this side, saying, oh, okay, that'll solve it. I can break the experiment by contriving some weight relationship over here. So when he puts the 1 mass out here, okay, and the 2 mass here, all right, he gets a different amount of energy here. Now, there's lots of things you could say. First, you say, look, his lever is totally unideal. It's wood. All right. Now, the heavier the masses are relative to the wood, the more likely it is the wood's going to bend. Okay. So obviously, when you have the 1 mass out here, it's more likely to bend the wood than the 2 mass here. So any idiot could figure that much out. More wood surface. And then he has a stop. Now, obviously, he could push against the stop harder, too, and also flex the wood. So anything that puts spring energy into this piece of wood is going to change the outcome. So I would say the obvious probably solution to why he got a different result. And let's understand, he got a different result. The 2 should be the same. Should be the same energy. And so he got a result that's a little less. He doesn't explain how much less this is. He doesn't explain how that fits his theory. He doesn't explain how, oh yeah, that's perfectly in line with what Professor Lewin says happens. He doesn't show how this means anything in any place in physics, where I can take that piece of information and compare it to any experiment any physicist has ever done. So it's useless information, really, because it doesn't show anything real. All right, so the simple argument I would make is that he's pushing the lever against the pivot. He could flex the wood. At the beginning, when he has the 1 mass on here, this is where he's pushing from, is where the mass was. So in one case, he's holding the stick. In the other case, he's holding the piece of the weight of the mass. So who knows whether he's doing anything consistent. So the very fact that he still doesn't want to do quick release or consistent release, those things don't mean anything to him. He doesn't work on devising, making sure he's created systems that can't be fucked with by his own, irregularities. Irregularities he puts into the system. But let's say there are none of those. Let's say he has it pushed a little harder on one than he did the other. The simple truth is that the starting energy, okay, for this one is obviously with a mass on here, it's going to lag a little. There's more pressure on the wood. So the wood will flex, okay? The wood will bend a little bit instead of, okay, moving forward. The stick will move, but the mass will be lagging behind. So there'll be essentially a bend in the wood for the 1 mass. And that bend doesn't show up over on this other side. And because he's stopping the energy before it all goes back, that means you can't get the flex energy on this side ever. Okay, can't collect it. So you put a little bit of energy into this bend, and the bend is never goes away. It's still there when this thing's released. So you stored some energy in bending the wood, and that stored energy just can't get to this side because you're not going to release all the energy. You're only releasing a specific amount of movement. And you've stored, right in the beginning, you stored some energy in flexing the wood. Now, the fact that he has a bunch of holes drilled in the wood just makes this even more likely. Okay, so it's even more likely the wood is going to bend because of those thin pieces of wood areas. All right, so simple enough explanation. But he'll provide none. He'll just say inertia, okay, but it won't have any mathematical integrity. It won't have any rational integrity. He won't explain how it works, this inertia thing, how light things have more inertia in some way. They resist moving in some way more than heavy things. It's just nonsense. I mean, I've tried to do this before where, you could just reduce this all to little pieces. Just like you could reduce the earth to apples. You could just make the whole earth out of apples. And the truth is I could just take any one of the apples and put it 5 miles away in space, and it'll do exactly what the earth is doing. Okay, it'll retain its identity. Okay, it'll have the same motion, the same everything. It'll orbit the sun the same way. It'll do everything the same. Nothing else changed. If we eliminate the fact that it's going to be gravitationally attracted to the big apple. But anyway, the earth. So you can particularize everything. And that's what you're doing with these experiments. You're saying you have a mass. And, if I drill a hole in the wood here and I have a heavy piece here, it's all about just how fast these little pieces will be going. So you're just saying, where's the piece? Where's there a piece of mass? So let's make all the passes the same. So we know the mass of each object is exactly the same inside of this thing. They're all apples. They all weigh the same object. And all you're saying is by position, it's going to be moving a different velocity. So when I rotate this, I put energy into it. Okay, all that's going to happen is each one of these little pieces is going to start gaining a velocity, and they're going to have a momentum. And their individual momentum adds up. So the dense part, where you have a high density of apples, well, those little apples are all going, oh, look, they're going very slow. And then you have the less dense, but they're going to be going very fast. And it's just, you just add up these, MVs. You just add up, in this case, it's all the same M, and you're just saying, what's the velocity for this one? What's the velocity for this one? Velocity here, velocity here, velocity here. You take the total and you do an average, and that's what you have as a total momentum. But that's all there is. There's just atoms moving. And, 50 atoms going twice the speed is the same thing as 100 atoms going half the speed. I just don't know how you can't understand. One atom going 1,000 miles an hour, 1,000 atoms going 1 mile an hour. Same energy, same capacity to bang into things and push them. Energy can only be transferred. That's a concept you don't believe? You don't believe that energy can only be transferred. It can never increase in a system, ever, or decrease in a system. You can only transfer it. And the kinetic energy fails dismally, okay, in all of these experiments where you use a device that can convert one MV into a different MV. And it's the same total MV, but big M, little v, and I use some device to make big V, little m. Every single time you do that, your kinetic energy theory is going to make or destroy energy. And that's just not right. And you know it. You assholes do not believe it takes 25 times the fuel to spin a wheel 5 times as fast. You do not believe that if I had a water wheel and I spun it 5 times faster with the stream, that it's going to do 25 times the work. You don't believe any of that crap. So why are you defending this nonsense theory? No, it's just so bad. Humans suck. It occurred to me that, Planet of the Apes, oh, what a terrible thing. No. I mean, if I could, right now, just press a button and I could be in a cage on the Planet of the Apes, I'd rather. Humans are awful, terrible, disgustingly putrid, monstrous, lying sacks of crap. All right, that's a fact. And at least those apes had the integrity. Like I said, I would rather argue with the apes than argue with you morons because you're so dishonest. Such despicable pieces of shit. Ugh.